Alright, time for another DraftPhysics.com, debatephysics.com also. Video presentation. So the same arguments over and over. There's parts of physics that just don't make any sense. They say it, they don't say too often because frankly it's so ridiculous. So the kinetic energy theorem, this idea that there's something called an mv squared, some kind of real concept, is what it basically states is that there's this quadratic increase in your energy with a doubling, a tripling, a quadrupling of velocity. So twice the speed is 4 times the energy, 3 times the speed is 9 times the energy, 4 times the speed 16, and 5 times the speed is 25 times the energy. That you can, the overt statement they make is you can do 25 times the work because kinetic energy does work. And I've demonstrated that it never does any work. It doesn't move rockets. It doesn't turn gears. It doesn't do anything hydraulic pressure wise. There's just a ballistic pendulum. You can't collect this kinetic energy ever. There's only a few little rickety experiments that have some indication of its reality, and all of those can be understood as having flaws, okay, in terms of completely ignored variables that are causing the effect. So I could argue that there's some, a little bit of experimental evidence in the sense the Mythbusters did crash cars, 50 miles an hour, 100 miles an hour, and there was no 4 times the crushing of metal, just the expected twice. So it's a silly statement on its face. I don't know how anybody who's been on Earth a while could actually think it takes 25 times the gasoline to go 50 miles an hour versus 10 miles an hour. I don't think anybody could believe that. And I've used the example of spinning something, and like a drill, and to spin it twice as fast as 4 times the energy. No. And 5 times as fast would be 25 times the electricity, which is just too ridiculous. So anyway, this is what I'm arguing to intelligent physicists, and they're just ignoring the argument, okay? Pretending it doesn't exist. And it's decisive, and I shouldn't really have to keep doing this. The only thing that does anything in the universe is momentum. The mv part. The squared part is just a fable. There's no such thing. It's a pixie. It's a fairy. It's nothing. All right. So I can use, I'm trying to come up with examples that make it really clear that all this bullshit just shouldn't be an argument. So you could use something like pool balls, and people can understand that, when you break some pool balls, that you're just going to transfer the momentum. So you'd have a high velocity here, a big arrow, and that all you can transfer, okay, is that arrow to these other balls. That is, you can give a piece of it to this one, and you give a piece of it to this one, and you give a piece of it to this one, and you give a piece of it to this one. And all you're going to have in the end is what you put in. So the same amount of mass moving, the same amount of mv will be in here as you started with here, and that will be conserved. And they say this word like, momentum is conserved, but they ruin the concept by thinking that going this way somehow undoes going that way, and you don't have to count those momentums. So theoretically they're almost arguing that the motion this way is canceled by the motion this way, and that momentum isn't real in the universe somehow. And obviously it's a ridiculous idea that you can cancel motion. Motion can't be canceled. Mass having motion can't cancel, and it can't and it can't anti, and it can't do any of that nonsense. It's always mass moving in the universe. It's always real, and so there's just you're saying, how can an honest person not concede these these basic ideas? Now the interesting thing with this example, just because it illustrates how careful you have to be when you're doing experiments, is that I could do this pool ball example, and I could have an object that's just vibrating. I could just have a little, it's just vibrating. It's just got motion in it, but it's, vibrational motion. And it could be vibrating in any direction. It doesn't have to be this way and this way. It could be up and down, could be any way. And the fact is that I could just put this in contact with these balls, and that vibration, okay, the energy of that vibration will be converted into this and this and this. There will be, in fact, a conversion of this very high vibrational MV into lots of other MVs. And just a fact that you can do that. It does happen in the real world. And so I was thinking of applying that to the logic of air tracks, which when you often see air track carts, they are jiggling. So they do have some energy in them. And this was a problem also even when you're doing pendulum experiments. If you have some motion in the pendulum, if it's got some oscillatory motion in it as it falls, that also is going to count as real MV, if you convert it into, if you exchange it with some other object. So it's just another one of the obvious variables of doing physics. And again, this comes down to, this argument that I should have to make these arguments to physicists, that it's a problem, that if you're going to do an experiment where you're measuring linear motion, you have to account for the, yes, you have rolling wheels. If you have rolling wheels, then you have also angular momentum. And the two of them are independent of each other. So as much as the wheel looks like it's part of the car and it's doing the car thing, it's really independent. In a sense, you might as well calculate it as just being a flywheel that's, stuck on top of the car spinning. And you're going to, you can decide to engage the flywheel or not engage it. It's just stored energy, and that's what's in the wheels, is stored energy. It took more energy to move the car, depending on what kind of wheels I put on here. If I put big heavy lead wheels that store a lot of momentum, then it's going to be harder to push that car, because I have to give those wheels angular, I have to give them their angular momentum with whatever force I'm applying. So I could apply the same force to two cars, one that had very light wheels with a very small radius, and ones that had very big wheels with a very high radius. And the fact is, the heavy wheels with a high radius, that is a big radius, are going to store more. Just a fact. The catch there is that, see, the small wheel okay, means that you have to go for, as any linear distance you go over, you rotate more times, so you have to have a much higher velocity. So I should have done the better example, which is lead small wheels and light fluffy wheels. The other point is though, the other catch to momentum when it's trapped in wheels is that if you have the same rotational speed, like if I want to spin something the same speed regardless, then obviously when the mass is on the outside, it's going to have more momentum. Alright, but I mean, these are all parts of physics. This is real physics. I mean, and they're just ignore all of these facts. So it's just like the wave-particle duality, where they ignore all the facts that are glaring. The double maxima is saying, what is this about? Why is it there? And they just ignore it altogether. So they have lots of reasons to doubt and question, and instead they are just believers. So it is in fact just a religion, is what it comes down to. There's not much else to say. Alright, so with that preface, we'll go to something probably ridiculous, no waste of time. So I'll play a critic video that just has a title that compels attention, in the sense that it's some sort of argument where he's going to make an argument saying, that he's going to explain levers. So it's titled DraftScience Lever Nonsense. Now, I don't think I've said any nonsense about levers. I really don't think I've stated anything that's nonsensical about the basic function of a lever, and that there's a law of the lever, and it establishes certain rules about conservation, frankly, that what's going on one side has to equal what's going on the other side, and these are well established. So they're Archimedes style rules, okay, that basically state that if I did have a balance or a lever, and I had a 2 mass at one distance, and I have a 1 mass at two distances on the other side, that this is a perfect equality, that these two objects essentially weigh the same according to this balancing fulcrum. Okay, it's going to state that yes, those two things do equal each other, and I can oscillate it. That is, I could put energy into it, and it will oscillate back and forth with the 1 mass going twice the velocity, and with the 2 mass going 1 velocity. Perfect equality. Now, there is no equality in terms of their kinetic energy, and that's the problem with their theory. That's the nonsense they're preaching. And their argument is the real equality is 1.4. The velocity will equal a 2 mass with 1 velocity. Now, that doesn't happen. It doesn't balance. It doesn't work. And it doesn't have anything to do with being reasonable and rational. So, with that context, I will go load up the video. Well, unfortunately, he's playing clips of my video and then responding, so it's going to be probably pretty hard to hear anything. Yeah, because he talks funny. DraftPhysics.com, debatephysics.com also, but as stated...
Debate? Are you fucking kidding me?
Yeah, exactly. Where's your counter arguments? Again, I make hundreds of arguments in these videos, and I don't hear you counter them. So show me the evidence of it taking 25 times the energy to spin something 5 times as fast. Just show me where that happens on planet Earth somewhere. Show me, give me some logical indication that it's possible that it happens somewhere on Earth. That would be a debate. That would be arguing my arguments. Ugh, pathetic coward. The debate lacks any coherency in the sense of argument, counter-argument. So I'll just make these arguments again. No. So there's a whole bunch of arguments in this video. He's not going to get to any of them in this video, obviously, because he's only going to play about 3 minutes of my video. And so I go through the lever, I go through the ballistic pendulum, I go through the rocket ship. These are all really hard arguments to in any way counter. How do you explain away the fact that if I put something in space, I can't make it move with kinetic energy? It's just not possible for me to have kinetic energy interact with it and actually be conserved. I can't have no possibility unless I hit exactly the same mass object into it. There's just no way you can make that make sense to you. How do you make sense out of saying that kinetic energy does work when it can't move an object in empty space? That's a question that deserves an answer from you, putz.
There isn't just counter-arguments coming your way, there's counter-evidence.
I've already pointed out, the evidence is absolute rubbish. If you think your evidence is of a high enough standard to prove anything, that it would hold up to any kind of scrutiny, that anybody has ever in the history of science actually written a paper with an experiment as bad as yours, or brozos, or dispars, that experiments of this poor quality would actually get published. I mean, get serious. You're making a bold claim that you're going to prove levers don't conserve momentum. And I don't see your lever experiment, by the way. And so the subject is levers here.
To support those arguments, isn't there physical evidence that you can't handle?
No, you can't handle it, okay? So again, I could just go back to the Mythbusters. What's your bizarre, silly, nonsensical, crackhead explanation for why the car crushed exactly twice as much? And no indication of anything more than twice as much. Not a little tiny bit more than twice as much. No indication of 4 times as much. and say, come on, either be honest or to hell with you.
A little bit of projection there.
Yeah, yes, it's a direct statement. I'm saying it for the future. It's quite obvious that these people have no fucking intellectual character. The truth doesn't matter to these asswipes. Their petty little hatred is all they have. So, what they're claiming is that the law of the lever isn't true. So this 2000...
Nobody.
Okay, yes, exactly. So again, he's going to try to say that somehow the law of the lever doesn't demand conservation of momentum. And we know it does. You have to conserve the momentum. The law of the lever is basically making the point, okay? You can't get past what it says. Twice the distance times the mass. The distance times the mass, and the distance is the velocity. There's no way of changing the fact that the 1 unit of distance is 1 unit of velocity. 2 units of distance is 2 units of velocity. That's exactly what the lever does. And so if you're going to argue that 1 unit of distance is 1 unit of energy and 2 units of distance is 2 units of velocity, or energy, or momentum, then there's no way you can deny it. Oh, it's just amazing bullshit. You are saying the law of the lever doesn't work. Clearly and obviously. And, so this is their version of honest debate, is to sit there and make a claim that somehow, although we're overtly challenging the law of the lever, which was a conservation of momentum argument, and they're saying it's conservation of kinetic energy, which violates. Obviously, it doesn't conserve momentum then. 1.4, one mass going 1.4 is not conservation of momentum, okay? So if you put a one mass going 1.4 in and you get a 2 mass going 1 velocity out, you have created 30% more momentum. And if you do it the other way around, you've lost 30% of the momentum. That's not conservation of momentum. Oh, they're just so dishonest. Oof.
Is claiming that the law of the lever isn't true. It is true. You just strawman the arguments.
So again, this is just absolute bullshit. I draw it, and where's the straw man? You can't do the simple addition yourself. I have to do it for you. I have to actually sit there and write out, okay, 1 times 1.4 does not equal, 2 times 1. Okay, I have to do that for you? I've strawmanned the argument? No, you've lie-manned the argument. It's a year-old theory that the distance is proportional, completely proportional, to which you could argue would be the capacity.
The distance is completely proportional. What kind of ambiguous statement is that?
It's almost like saying it's exactly equal to. So the distance is equal to. Okay, the fact is, you use the word proportional to be just kind of careful because some things can have a little bit of variation in them. And sometimes it's just a proportional. That is, 5 equals 10 and 10 equals 20. And, they have a proportional relationship to their increase. Okay, not a quadratic one, but a proportional one. So that's why the word is used. Okay, but it's basically just saying the law of the lever is saying there's an equality between the distance and the velocity. It's saying there's an overt equality between the distance and the momentum. And obviously the only part you're changing is the velocity part. Something to balance or in the case...
Balance, yes. Think about that.
Case of
how helpful.
Representing a change in the direction of the energy, and that's what levers do. Okay, you put a force.
If it's balancing, how is it changing direction?
It's going up into gravity on the left side, and then down into gravity, and then upside on the right side. That's how it's balancing. It's oscillating. So again, this is who's playing straw man minutia verbiage games now. You're just going to play games with the fucking goddamn vocabulary, huh? In one way, you get a force back the other way, basically. And there's a lifting force. You put in a pushing force down, you get a lifting.
Yeah, but if you pushed it, you just said if you push it down, so you'd be adding more force then, wouldn't you?
Force. Exactly. You're adding force on one side, and you're getting the force, exactly the same force on the other side. That's the law of the lever. You dumb fucker.
Blah, blah, blah. And the argument is if
I put 9 pounds on one side, I get 9 pounds on the other side. Okay, I can collect it in any version I wish to in terms of a mass and a velocity, but that's the amount of pressure I'm going to have. Is what does 9 pounds of force do? I can create 9 pounds of force on the other side of the lever, and I can have it do it with a 1 object going 9 velocity, or I can have a 9 object going 1 velocity.
you're at the same distance, okay, from a fulcrum, that it's equal. And if you change that distance or you change the mass ratio based on distance, that you'll be able to create an equality. So
that's the law of the levers, just the simple relationship that the distance is proportional to the momentum.
Yeah, if you change masses and distances, you can get an equality, yes.
You have to conserve the momentum, and an equality that conserves momentum. So so you're again just cheating the argument. You're defending kinetic energy, so the kinetic energy changes. If I use a one object going fast, it's completely different than a heavy object going slow. So your theory doesn't allow you to do that. So you just basically just lied, okay, saying, oh yes, of course, you can change the mass and get a different velocity. No, you can't, because you aren't going to conserve your precious kinetic energy that way.
I did a 4-to-1 relationship, but in this case we'll just do a 2 mass here would be the same as a 1 mass here. They would weigh the same, so it would balance.
Right, how are they weighing the same?
Oh, brother, in gravity, retard. It's retarded, right? Yeah, he's retarded. And because gravity is just giving things momentum, is the simple argument, right? So gravity, things fall in gravity. What's gravity doing? It's giving things momentum. And so the simple truth is in this circumstance, gravity is giving the two objects momentum as they're tied to this lever. So the one object goes 2 units of distance. For every 1 unit of distance, the object goes. And so in their gravitational balance, that's what's being balanced, is their momentum. Their gravitational acceleration is being balanced because of the fact that neither one is going to fall at a free fall speed. Okay, if I made those masses just subtly off, it would just slowly turn the lever. The lever wouldn't go free fall speed.
You've just said we've got a 2 mass and a 1 mass. So how do they weigh the same? They don't weigh the same, do they?
Okay, so we know they do weigh the same in the sense that if I just break the lever in half and I just measure the pressure of the 2 mass at 1 distance, or that I measure the pressure of a 1 mass at 2 distances, they will weigh the same. The scale will read the same force. So I can't change how much force they're applying to their side of the lever. So again, this evasion of the subject, he knows that's absolutely true. That if I actually did put a spring and a scale and I measured how much force the one was putting on one side, the lever, and then I measured the 2 mass at 1 distance, that they're going to weigh the same on the scale.
Balance. Gravity would give them the same momentum into the lever.
If they're balancing on the lever and they're not moving, how are they?
So again, are we to pretend that a rational person talking about physics is going to say they're not moving? That there's no energy in any system that looks to us like it's not moving? Like that doesn't mean there's tension in the system? Of course there's tension in the system. Of course you can know that the system, even to balance, you can watch it do that subtle little tiny motions that it does to balance.
Where's momentum in all this? They're not moving.
They don't have to be moving to our perception. They just have to have a force being applied to them. So again, we know the two forces are equal, and that's why it's not moving to our perception.
And produce an equality, stating basically that these two objects weigh the same, even though their masses are very different.
So you acknowledge that the masses are different, yet they weigh the same.
Amazing. Yeah, yes, we're weighing them. The weighing is different than what's its absolute mass. Weighing is an actual event that takes place. Like, I could weigh something this way in gravity, or I could weigh it this way. I could just have it move into the scale, and I could measure the pressure it's putting on the scale, and it's going to be exactly the same. This force, if it says 1 pound this way, isn't any different than 1 pound this way. So yes, weighing is a little different than absolute mass.
But one's twice as massive as the other, so they don't weigh the same, do they?
Okay, we know we're weighing them. We're actually doing that with this process, so it's just ridiculous to say they don't weigh the same when, of course, if they weigh the same. A small mass can weigh an awful lot if I give it enough velocity, and a big mass can weigh nothing if I give it no velocity. So it's just the fact that he doesn't know the difference between mass and weight, okay, and the fact that weight is associated with doing some kind of work on something, that you have to acquire something's weight, you have to test it.
Because of the forces are essentially equal.
No, the forces aren't equal. That's a 1 mass and that's a 2 mass. So that 2 mass has got twice the force of that 1 mass. So the forces aren't equal, are they?
So again, we know that under this circumstance, stuck to that lever, they are equal, because the 1 mass has more liberty to move than the 2 mass. The lever is part of the experiment, and it's changing how much velocity they can acquire. So it's changing how they're moving in gravity. One of them moves less distance in the same time.
Being applied against each other in this manner, okay, where you change the distance from a fulcrum. And
all right, so just recognize the dishonesty of this, right? The claim is simple. The law of the levers existed for 2,000 years. It establishes this clear relationship between distance and mass equaling a momentum, and that those numbers have to be equal. So that's what the law of the lever says. His obligation is to show us that the law of the lever needs to be adjusted to account for the 1.4 thing that's going to happen. That 1 mass has, in fact, at twice the velocity, it would have way too much energy. Okay, and so that's his obligation, is to show how that 2,000-year-old calculation doesn't give the right answer, and why it doesn't give the right answer. Because it doesn't. The 2,000-year-old calculation says the 1 mass does in fact equal the 2 mass. A 1 mass going 2 velocity.
There we go, distance, which is the law of the lever, force times distance. So, as I've just said there, we've got a 2 mass.
Right, and so that's the established law of the lever. You're making a claim that somehow you don't have to conserve momentum and that it's going to leave with 1.4. Where's your evidence of that?
Mass. So that got 2 units of force, and it's 1 unit of distance. Force times distance, 2 times 1 is 2. And then on the other...
Now, you can't say there's 2 units of force. You have to say 1.4 units of force.
Other side, we've got 1 unit of force at 2 times the distance. 1 times 2 is 2. 2 and 2.
Right, so that's all momentum. Again, the distance is velocity. You can't deny you can't deny the fact that there's... So again, he's pretending that we don't know that if you have a rigid lever, okay, twice the distance means twice the velocity, twice the distance in its motion. And so it has to move twice the velocity. It can't move some other amount. So there's no way he can make this argument that it leaves 1.4 when the lever itself moved 2. So you can't make the argument. There's no way this side can move 1 unit of distance and this side can move 1.4 units of distance on the lever itself. That can't happen. The physical lever can't do that. So you can't argue for the velocity and then say the lever's moving the momentum velocity, but the object will leave with the kinetic energy velocity. So somehow the lever's moving with 2v, but the object will only leave with 1.4. That is too insipid an argument for somebody to make.
Is equal, and therefore it balances.
Obviously, I'm arguing the distance from the fulcrum really just means and just represents a distance, and it just represents the fact that this will move twice as much as this will.
But again, it wouldn't be moving, would it?
Of course it's going to be moving. So again, what's the point of arguing with people who just don't want to... Again, is he on the subject? Is he paying any attention to the fact that the lever itself creates this physical proportionality that you can't deny? 1 unit of distance is 1 unit of up and down motion. 2 units of distance has to be 2 units of up and down motion. No way to deny it. No way to evade it.
Balancing. If you add something to it, the whole system moves as one.
Yeah, it oscillates, which is the same thing as a balance.
It doesn't, you could put something, you could balance it with 10 times the mass, 10 times further out, and so on, and move it, and it becoming 10 times as fast, but it wouldn't move, it would just balance.
10 times as fast, he just said. It wouldn't move, it would just balance. How does it balance without moving? So again, this is just so ridiculous.
Unless you add something to it, and then the whole system will move as one. And of course, yes, it makes no difference. You could put fucking 30 times further out and so on. But ultimately, it would just stay there and balance.
So did that make any sense? No. Did he draw us a picture? No. So there's no way the physical lever can do anything other than these proportions. And you just have to explain how something can move 1 unit of distance on one side, one distance, and somehow can move 1.4 units of distance on the other side, even though it's 2 units of distance away. That's your obligation. And obviously you're not going anywhere near it. And then you're saying, I'm the one evading debate. No, you're evading debate.
In the same time. So all you're doing is changing the velocity. So a 2 mass at 1 velocity equals a 1 mass at 2 velocity. Now.
Oh, dear.
So he says, oh dear to that, when that's exactly what the physical reality produces with pulleys. And with, I can make an oscillator where it's balanced, and I can put the energy in, and that's exactly what's going to happen. And I did it with a 4-to-1 relationship. So, a 1 mass going 4V and a 4 mass going 1V, and it balances perfectly. The oscillator keeps oscillating until the energy slowly leaks out. No evidence that there's more energy on one side than the other.
All right, so the law of the lever was basically just say mass times distance. So 2 distance.
No, not mass.
Yeah, it's mass times distance. So he's saying no to that, and that's the law of the lever.
Times distance, force times distance.
No, it's mass times distance, but whatever. There's just no point in arguing with cheaters.
The mass gets the force, obviously, from gravity, because that's where the force is coming from gravity. You've got the mass, which you've got gravity accelerating, and that's equal to the force.
Yeah, exactly. So what's the point? What's the point of arguing about the mass not generating the force, when, of course, the mass is what collects the force? Duh.
Force.
This is times the same mass, 1 distance times the mass. Those are equalities. They're saying that doesn't happen. That I put the 2 mass in with 1 velocity, and I only get a 1 mass going 1.4. Now,
right, who says that?
Oh, brother, motherfucker! I think I have to go. Is that just too pathetic? Yeah. So this is really enough of right. I've made 73 or 4. I don't know how many videos it is with the title. Lever paradox, Steve Mould's lever paradox. I made the point that a guy getting millions of views for a video is saying that that's what happens. Okay, levers don't conserve momentum. He's overtly said it on a video. It gets millions of views. That's the whole point of me making the videos, is to point out that not a single fucking person with any character could show up and say, that doesn't happen. That's nonsense. That's idiotic. And this motherfucker can't even follow along. So he says he's honestly engaged in this debate or this conversation, and he's doing his best somehow, and he hasn't picked up on the idea after I've made close to 100 videos with the explicit title addressing the issue. Oh, yeah. So maybe this is the end of the video. I just can't see the point in interacting with people this dishonest. Who's saying that? Ugh. Everybody who opposes and down thumbs and all this other bullshit, you and your club, that's who's saying that, you fucking idiot. You were saying it, you idiot. Oh, damn. Amazing. Alright, I believe I will end the video here. I mean, it's just... this is just swimming in a cesspool to interact with these people. So we know that Archimedes, thousands of years ago, we know he isn't thinking of mv squared. Okay, nobody references Archimedes as the origin of the idea of kinetic energy or something. There's no previous statement about anything called mv squared until Leibniz popularized it. Okay, before that, it just doesn't exist as an idea. Okay, so anything more than whatever 276 years ago had no reference to any kind of living force, kinetic energy. So we know the law of the lever was explicitly what it was, a conservation of momentum argument. It was conservation of the quantity of motion, as Newton would say, or Descartes would say. That's the only rational way to understand Archimedes' arguments and what he was saying about what equals what, and that this is a conservation argument that he's making. All right, and what's being conserved is momentum. So there's no rational argument that 500 years ago anybody thought levers were conserving something other than momentum. And clearly the argument by the defenders of kinetic energy is that somehow the lever conserves kinetic energy and it doesn't care about momentum. Momentum can be thrown away, okay, in gratuitous, in huge, gigantic amounts. So if I make this the bullet and the gun, I end up throwing away 99.99% of the momentum. Okay, if I think of this kinetic energy theory meaning anything. So it's just nonsense. To argue he doesn't understand what's being argued is just so ridiculous after that 1.4 crap has been thrown in my face for more than 3-4 years now, and he doesn't understand that's what the argument's about, whether or not this one mass moves with 1.4 or whether this one mass moves with 2. And clearly Archimedes says it moves with 2. Alright. So anyway, till the next time and such. I hate this planet of lion scum.